Hello, welcome to Math with Mr. Dobrescu to the rescue. Today we are going to continue to practice adding, subtracting, multiplying, and dividing numbers in scientific notation. I decided to take another day to practice because many students are still struggling with adding, subtracting, multiplying, and dividing numbers in scientific notation. And let's make it really simple. We are going to follow some simple steps in order for us to get to the answer. Let's take a look at this example here. We have 5 times 10 to the negative 5 plus 2.46 times 10 to the negative 3. Remember, anytime we add or subtract numbers in scientific notation, the exponents of 10 have to be the same. Because remember, if we get the exponents of 10 the same, then we just simply add or subtract the numbers. Okay, so let's see how can we make the exponents of 10 to be the same. Okay, here we have 10 to the negative 5. And remember, if we try to change 10 to the negative 5, right, if we go from the end of 5, and we are moving the decimal one place to the left, we are increasing the exponent here. So here we are going to add a 1. And I think this might work if we do something to the first parenthesis in order to change 10 to the negative 5 to change it to 10 to the negative 3, right? But how many places do we need to move the decimal point? So if I move one place, we're adding 1. Negative 5 plus 1 becomes negative 4. But we need negative 3. Okay, so we need to get 10 to the negative 3. If we move one place, we get negative 4. But if we move 2 places, then we are going to add 2 instead. So adding 2 instead. So for each place, we're adding a 1. So now negative 5 plus 2 is going to become negative 3 and is going to match. Okay, so let's do that. Okay, so let's, again, like I said, we are going to change the 5 or 5.0. We are going to move the decimal to the left 2 places times 10 to the power of negative 5 plus 2. Each place we add a 1. Remember, as the number decreases, the exponent increases. Okay, so let's see what we get. So this becomes 0.05, so 0.05 times 10 to the negative 3, right? We change that into this now. And everything we have plus 2.46 times 10 to the negative 3. Now we can say that we have the same exponents. 10 to the negative 3, 10 to the negative 3, and now we just have to add the decimals and we get the final answer. Let's add those decimals now. And then it's going to be, everything is going to be times 10 to the negative 3. Because we did this change in the beginning, right? Now we get the exponents the same. Let's add this by the side. So we have 0.05 plus 2.46. 6 plus 5, 11. 1 carry the 1. 4 plus 1, 5. And 2 plus 0, 2. And this becomes 2.51. 2.51 times 10 to the negative 3. And this is our final answer. Okay, let's take a look now at an example where we have a subtraction. And it's the same thing. We need to change the exponents of 10 to be the same. What's better to do? If I move to the left one place here, I need to increase the exponent, and that will give us a 7. Take a look. If we move to the left one place, we are going to increase the exponent by 1. And it's going to work. And it's actually pretty easy. It just caught my eye, and I went right there into this example here. So now, here instead of 2.45, we are going to have 0.245 times 10 to the power of 6 plus 1, which is 7. Okay? We change this into this, right? By moving the decimal right here. And now the exponents are the same. We have 10 to the 7 here and 10 to the 7 here. Let's rewrite this down here. So we have 7.8 times 10 to the power of 7 and the minus 0.245 times 10 to the 7. Now since we have the exponents the same, we are just going to simply subtract these numbers. We're going to subtract and get the answer. And everything is going to be time 10 to the power of 7. Let's subtract 7.8 minus, remember, line up decimal places, 0.245. And in this case, we need to add a couple of zeros for the placeholder. Let's add the 0 here and the 0 here. We cannot take away 5 from 0. We need to borrow from the 8, make 8 a 7, make this 0 a 10, and this 0 a 9. Be very careful. And let's subtract. 10 minus 5 is 5, 9 minus 4 is 5, 7 minus 2 is also 5, and 7 minus 0 is 7. So our final answer is 7.555 times 10 to the power of 7. And we are done. Let's take a look now at an example where we have multiplication. And remember, with multiplication, since multiplication is commutative and associative, we can rearrange the parentheses. So let's regroup 7.2 and 4, the whole numbers in the decimal, the whole number in the decimal. Let's regroup these two together. So we have 7.2 times 4. We are going to put both of these in a parenthesis, regrouping it together, and times, and let's regroup the exponents of 10 in another parenthesis. 10 to the negative 1 times 10 to the negative 7. So we can use some strategies in order for us to get the answer. Now since we have the numbers here, we can just multiply 7.2 times 4. Let's see, 7.2 times 4. Let's multiply. 4 times 2, 8. 4 times 7, 28. And then remember, now at the end, we move the decimal point right here. And this becomes 28.8. 28.8 times, and remember, if we have the same base, one of the rules of exponent, keep the base, which is 10, and add the exponents, negative 1 plus negative 7. So we have 28.8 times negative 1 plus negative 7 becomes negative 8. 10 to the power of negative 8. And the question is, are we done? And the answer is no, not yet. Because 28.8 times 10 to the negative 8 is not written in scientific notation. Remember, scientific notation, the decimal has to be placed between the first and the second digit. So in this case, we have to move the decimal point to the left one place, and here we are going to increase the exponent by 1. And let's see what we get. So the final answer would be 2.88 times 10, negative 8 plus 1 becomes negative 7. Okay, that's it. Let's take a look now at our final example. Here we have a division. And remember, with a division, this division problem is written this way, horizontally. But now we can change this division problem and rewrite it as having a numerator divided by a denominator. So we can write this as 2.8 times 10 to the power of 4 divided, this is the same thing, right? Divided by 2.5 times 10 to the power of 6. And now let's see what we get. And remember the other day I showed you, after we do this, right, we are going to use the product of quotient property, right? So now we can change this into 2.8 divided by 2.5 times 10 to the power of 4 divided by 10 to the power of 6. Because this is the same thing, right? We just rearrange it together. We group the decimals together times the exponents of 10 together. So now we are going to divide 2.8 by 2.5, and then we are going to use the roots of exponents to change this 10 to the power of 4 divided by 10 to the power of 6. But let's divide this first. And remember, when we divide 2.8 by 2.5, we are moving the decimal to the right one place and make that the whole number. So that becomes the same thing as 28 divided by 25. 28, top dog inside the house, divided by 25. Okay? And let's see, 25 goes into 28 one time. 1 times 25, 25. Let's subtract. 28 minus 25 becomes 3. Now, add a 0 and a decimal, bring down the 0. 25 into 30 goes one time. 1 times 25, 25. Subtract. 30 minus 25 becomes 5. Remember, add another 0 and bring it down. And 25 into 50 twice. 2 times 25, 50. So we are done. So 2.8 divided by 2.5 becomes 1.12. And times, and remember, based on the quotient of powers property, we keep the base, which is 10, and we subtract the exponents, 4 minus 6. And let's see what we get. 1.12 times 4 minus 6 becomes negative 2. 10 to the negative 2. And this is our final answer, because this number is written in scientific notation. Remember, the decimal is placed between the first and the second digit times a 10 to an exponent, in this case negative 2. Okay, I hope after this, all of these 4 examples, now we did a division problem, we did a multiplication problem, we did a subtraction problem, and we did an addition problem. After this example, I know that you are more confident and you are ready to do more problems and get all of them right, because now we practiced more how to add, subtract, multiply, and divide numbers in scientific notation. Thank you all so much for watching. Again, I appreciate you liking this video and subscribing, and please share this video with your friends, and make sure you stay tuned for our next video. All the best to you. Take care.